Welcome to this module on modular coordination in prefabricated structures. Myself, Dr. J. Abdul Bari, working as Associate Professor in the Department of Civil Engineering of K.S.Rangasamy College of Technology. In this video, we are going to learn how modular coordinations helps in standardizing prefabricated constructions for better efficiency, quality, and compatibility. The contents which are going to look into this video are modular coordinations, the definitions of modular coordinations, the rules for meeting the requirements of conventional and prefabricated constructions, prefabricated modules, classifications of modular coordinations, and modular reference systems. First of all, we have to look into what is modular coordinations. Modular coordinations is a systems where building components are designed and manufactured off-sites in standardized dimensional units. Typically, the basic module, that is capital M, is set as 100 millimeters, and the components are created in multiples and submultiples of these basic units. This approach helps components fit together perfectly when assembled on sites, leading to improved the quality, reduced waste, and faster constructions. The basic definitions of modular coordinations is modular coordinations is a concept of coordinations of dimensions and space in which building components are positioned in terms of modules. That is, one module is equal to 100 mm. Next, we will look into the rules adequate for meeting the requirements of conventional as well as the prefabricated constructions. So, in terms of planning grid systems, for residential and institutional buildings, we use 3M grid in both the horizontal directions. And for the institutional buildings, that is industrial buildings, based upon the height, the grid size will be vary. That is 15M grid for the span up to 12 meters, 30M grid for the span between 12 to 18 meters, and 60M grid for the span over of 18 meters. The center line of the load-bearing wall should coincide with the grid lines. Next, grid line placements. The load-bearing wall should be aligned with the grid lines. And in terms of external walls, the grid lines coincide with the center line of the wall with an offset by 5 cm from the internal face. Whereas in the internal columns, the grid line coincides with the center line of the columns. Next is vertical planning models. In case of the height increments in multiples of 1 module, 100 mm, and standard increments for the doors, windows, and other openings will also be kept in case of vertical planning modules. Next, we will look into the types of the prefabricated modules. So, prefabricated modules of three-dimensional constructions are composed of the force-shaped assembled panels. They are four-sided panels, partially open-side modules, open-sided modules, and modules supported by the primary structures. In four-sided modules, we will look into that fully enclosed on the four sides, and it is suitable for the hotels, residential buildings, and housing compounds, and it transfers both the vertical as well as the lateral loads. In partially open-sided modules, some of the walls don't space the entire wall length, and it is used for accessways and the corridors. Next, in open side modules, one or two sides are fully open, and it is ideal for the spaces like hospitals and schools, which are allowing the flexible space creations. Next, modules supported by the primary structures, that is, modules will be supported by the external steel frames, and it is suitable for the residential or mixed use of the buildings. A model is the basic dimensions, which could be examples from the basis of the planning grids in terms of multiples and submultiples of standard modules. So the modules has been classified into as basic modules and submodules, and as well as the multiple modules, which is further classified as a horizontal module and vertical module. So the basic module will be given as the M, whereas the submodule is the one fourth of the M or half of the M. Whereas the multiple modules based on the height, it will be vary. In the vertical, it will be of 3 meter and 6 meter. In the horizontal, it will be of 3 meter, 6 meter, and up to 60 meter. So the basic model, it is the fundamental unit of size in modular coordinations and in general for the applications to the buildings and components. The size of the basic module is taken as 100 mm, which has been denoted by m. Whereas in multi-module, the multiples of basic modules usually expressed in terms of m's with the numerics as 2m, 3m, 4m. Whereas the submodules is smaller than the basic modules. For practical considerations, this submodular increment will be expressed in terms of m as 1/4 of the m, 1/3 of the m, or 1/5 of the m. So the importance of the modular reference system is it simplifies the design, manufacturing, and assembly, and it ensures the components which are easily interchangeable, and it enables the efficient mass productions with fewer errors and facilitates the construction timelines and cost savings. And in conclusion, we can able to say that modular coordinations provide a structural approach to prefabrications by standardizing component dimensions. This ensures seamless integration of the components, which reduces the material waste, better quality control, and faster constructions.